is it working or not.
Mm-hmm. Okay. And then it'll probably be with the other email or this one.
Okay, so in this time, you can simply log in your Gmail account, then it will
Okay. Okay, that sounds good.
58@gmail.com, which you provide me this email I want to use and provide this. Yes.
Okay. Yeah, sounds good. Okay. Yeah, I can try that later because I have to log out of everything here and then log into my other account.
Okay. So I hope it will work, no problem. And further you can easily access it. Then you can also watch the recorded class for the lifetime. Anytime you can.
Yeah, that sounds good.
So let me share my screen and then start the session. Can you see my screen?
Yes.
Basically today I will welcome to monitoring water quality using remote sensing technique in Google Thinking with learning model. So basically today's session I will try to discuss about that remote sensing monitoring of total suspended solid concentration using Google Earth Engine.
Okay.
How we can easily monitoring that TSS, mainly total suspended solid concentration on the water body part, then we using the Google Earth Engine, as well as we also try to discuss about that how we can easily create type of time series chart, how the concentration is the high, how the concentration is the low, so that we can easily define about this type of things. Okay, so here you can see this is one kind of water body area in the lake. So here we find out that this type of result for the total suspended solid, and basically this type of red color identify about that high concentration for that total suspended solid, and this type of blue color identify about that low concentration. For the blue color is the low, red color is the high concentration about the total suspended solid. And you can see overall scenario of this water body, it's totally lot of total suspended solid you can find out. Okay, because all of material, all of cities washed just go to this lake, and then it creates this type of scenario. So it's totally polluted water body. We find out that with the high concentration of that total suspended solid. Okay, so basically total suspended solid is a concentration, is an important indicator for monitoring the coastal water environment quality and measuring the degree of water pollution. As well
really
as
quickly, your is this one being videotaped as well? Because I might forget stuff later.
Yeah.
Okay, perfect.
And TSS is the main cause of turbidity in the water. So turbidity, when the turbidity is the high on your water body, then also high for the total suspended solid. About okay. So now in this time, I will try to explain it how we can easily work with that total suspended solid. Here you can see this is the one kind of reference paper, and it's already published, and they are also work with that total suspended solid. So basically, in this time, they are use the Landsat imagery for doing these things. Here you can see in this time the full paper. I will send you this reference paper also. You try to read and get a lot of things. So basically, in this paper, they are using the MODIS satellite imagery as well as also Landsat satellite imagery to detect the water total suspended solid. Okay. So here you can see this is the study area, and in this time they are also take the some sample site. Okay, suppose here you can see this type of red color. They are take the some sample mainly ground truth data, and this ground truth data need when you want to work with the accuracy of your map. Suppose you want to calculate the root mean square error, and you want to check what the accuracy of your satellite data. Suppose I want to make the total suspended solid map using Landsat imagery. Okay, but I want to check what is the accuracy I can got from this satellite imagery data. So for checking this data, we have to use this type of sample site. Sample site, simply go to this water body and further we collect some water sample. Further this type of water sample we are just use here to make that accuracy. What is the accuracy we can get after creating this water body for total suspended solid map. Okay, so it's also important about this. I will show you that how we can easily check the accuracy using the ground sample data after creating this map. Okay, and further here you can see this is the location about that, and you can see data, materials and data set. So mainly in this time they are using the Landsat surface reflectance. Okay, and we already know about that. Previous class I discussed about the surface reflectance data set. As well as also you can see about that take the data set between this time period from that Google Earth Engine platform. Okay, in this time they are also using the Google Earth Engine platform to take the satellite imagery, as well as they are also take the TM image or ETM image. So different types of sensor in this time they are using here, and this is the Landsat imagery, and also take that MODIS, Aqua and Terra data have advantage of the high resolution, 1 to 2 days we can get. And it's also important for that MODIS, Aqua and Terra dataset. They are also used here for monitoring the total suspended solid. And also you can see about that they are also used at this the development about these things, and they are also used at that data from the Google Earth Engine platform. Okay. And further there you can see that hydrological and morphological data. They are also collect from here different types of data, and also you can see the in-situ data. So in-situ data mainly it's that ground sample data. Okay, they are also take the ground sample data and further check their accuracy about this paper, and then also make this type of concentration about that total suspended solid in the grounds on in-situ data, and then calculate the milligram per liter unit about that. So it's their ground sample data, and further here you can see in this time how we can easily use the satellite data for pre-processing to make the total suspended solid. Okay, for doing these things they take the less than 10% cloud cover imagery. Okay, we try to add the more cloudless image all the time. Okay, suppose I less than 1%, 2%. Okay, so first of all we try to take the very clear imagery. Okay, so in this time they take that less than 10% cloud cover imagery, and further they calculate the quality attribute or QA band algorithm amongst the cloud pixel. So they are remove the cloud shadow and also cloud, all of those things they are complete to take the your beautiful image or clear imagery without cloud. They also take about these kind of things after pre-processing the image. Also for the mode is also for the same. And now you can see here TSS retrieved from the Landsat and MODIS data. So basically they are derived from the TSS from that Landsat and MODIS data. And basically in this time here you can see they are first the in-situ data were matched to the corresponding satellite data. They are also doing here, and they are created a formula. This formula basically you can see, and in this time here you can see they are also applying this type of model. So this model create this type of formula. Suppose in this time you can see it's a blue band, green band, red band, and near infrared band. It's a hidden layer, mainly input layer. It's the input layer. So different types of input layer in this time they are considered only for the blue, green, red, near infrared. So basically 4 band from Landsat imagery. They are used here the input layer and also create the lot of hidden layer and then calculate the TSS. Okay, so it's one kind of machine learning method about that. And also do for that MODIS, they are also use this type of band. Basically it's one kind of MODIS satellite imagery band, and use the input layer, and further they are put here that hidden layer and also get the output is the TSS. So basically these things they are do for creating the equation. In this time here you can see after creating this equation they can get this type of it's basically accuracy evaluation. When you want to check the accuracy of your data, then we have to use this type of equation. It's the root mean square error And then we can easily check this equation. We can easily check about our accuracy of our model. And result. Okay, so here you can see for the accuracy comparison of different model, Lancet and Modis, we can get this type of equation. Here you can see. For the Lancet, we find out this is the equation. And here you can see green plus red divided by blue divided by red. So it's one kind of equation. And this equation is derived from the comparison of different retrieval model for Lancet and Modis satellite imaging. So we can get this type of model. Also here you can see number of modeling 187. But this is the model about that. So, and it's created from that mainly your model. Suppose Swiss model we just put in here. You can see this type of model. After putting this type of things, blue, green, red, near infrared, then we can create this type of equation or model. Here you can find out this type of model. For that Lancet TSS, here you can see this is the formula about that. For Lancet TSS 1.20 multiply with exponential with this value. Okay, so basically it's one kind of also you can see here x1 is x1 mainly you can see x1 is that formula green plus near infrared divided by blue plus blue divided by red. Okay, so this is the formula is the x1 and 1.20 and exponential 14.44 it come from our model equation. Okay. So in this time this type of things we are just use in our model and further we try to check about that total suspended solid. Okay, so let's go. Just I simply open my new code editor. Okay, suppose suppose I already imported shape file. Just I show you that. Suppose map.add layer.
Quick question. That
Please.
the paper you were reading, is that could I find that somewhere?
Yeah, you can easily get this paper. I will send you the link.
Okay.
It's already published. It's already published.
It looks interesting.
And in this time they are using the Lancet imagery. But in this time, this same model I try to develop in the Sentinel-2 satellite imagery. Sentinel-2 satellite imagery because it has a high resolution. That's why I just try to make the Sentinel-2 satellite imagery. Then we also get the more better result. Okay. So there you can see, this is my study area of this lake. Okay. So this is my study area. Just I simply draw the water body area. And further I want to check what the suspended solid for this water body area. Okay, so after getting this type of water body area, first of all, I need to need my satellite image collection. I want to work for that Sentinel. Just I simply click on here and click on the Sentinel. And further go to that Sentinel-2 multi-spectral instrument. And then put here robotic sphere reflectance. Simply copy. Oh, no. In this time we have the surface reflectance. Sorry, surface reflectance. Because this paper equation, they are using the surface reflectance imagery. So that's why I'm using the same one. Better, yeah. Surface reflectance imagery. So just I simply copy that from here. Copy. And paste in my intent. And then I put a name. Suppose I put the name is that, you can put any name as a variable. I put the variable name, suppose collection. Okay, you can put any name as a variable. So in this time, this is my variable name collection. In this collection, this is my image collection stored in this variable. Okay? And further, I just simply filter. Suppose, first of all, I simply use a function, filter bounds. So just put here that filter bounds, filter bounded with RY. Okay, this is my study area. And then put here that filter date. In this time, we put here the specific time period, your start time and end time. Suppose I put this time is that year of 2017. Suppose 1st January from year of 2022 December 31. Okay, and I also make the time series chart, so that's why I also make the time period, long time period. Okay, because it creates the time series chart also about that. Okay, and now further, I just simply put here that filter data and put here that cloud pixel less than 1%. Okay? Simply go to the image properties, and here you find out that property name cloud pixel percentage. Simply copy that.
Okay.
And paste here, and put here that less than 1. Okay. So this is my image collection I created in here. So now in this time, suppose you just print that how many image collection I can got. Just print this collection and run it. So now it shows about that how much image collection we generate from. We get the total 121 images in this collection. Okay. So now further, I want to just make once this image in here. So just take a variable. Suppose I put the variable name is that image and call my collection. From this collection, I create that median composite. Suppose put here the median, and then clip with my study area. Clip with the study area, which is RY. Okay. And now display this result. So map.add layer and call this image. So now it also added the image for our study area. We can get that Sentinel-2 satellite imagery median composite. Okay, it looked like that. So first I simply click on here. And I said that suppose B4, B3, and B2 custom as an expressing 98% and apply. So now we can got this type of imagery here. You can see I also import that and then copy this variable name and paste after the object name. I also put here it's a imagery. Okay, so now we can got our imagery. In this imagery you can see it look like that for our satellite imagery. It come from that Sentinel-2, and you can see this totally this type of water show this type of blue color, green color water body. Okay, so actually there are a lot of turbidity we find out, or there are a lot of total suspended solid or organic matter. Okay, so that's why it look like that. You can see it's a totally show about that this type of color. Okay? Actually there are a lot of turbidity, a lot of total suspended solid. We find out this water body. So this is our satellite imagery. We find out this satellite imagery. So now in this time we just extract the total suspended solid information and also make about the total suspended solid map. So for doing these things in this time, first of all we need to extract the water body. Okay, so from these satellite images we have to extract the water body, or you can see extract. I'll write the comment. Extract the water body. So now in this time from this satellite image I'll just extract the water body. And from the water body, I want to use the index. It's called that AW, automatic water extraction index. Okay, so AWEI. So it's one kind of index, whose name is the automatic water extraction index. Suppose I simply search on the Google. I simply search on the Google and put that AWEI formula. Then it provides me this type of formula here. You can see. Basically, this is the formula, or also you can see about click on here. Then you can get the more details about this water, automatic water extraction index. So you can see this is the formula, automatic water extraction index. And its formula is that 4 multiply with green band minus short wave infrared 2 band, subtract with 0.25, multiply with near infrared and then further just put here the 2.75, then we can easily get this automatic water extraction index. Okay, so this is our formula, and this formula we are just using here, and then we can easily get that water automatic extraction index. So this is my satellite imagery. So now from this satellite imagery I just extract the water body. So in this time I just put this formula. So take a variable, I put the variable name, suppose you can put any name as a variable. Here just put the variable name is that calculate. You can put any name. Suppose I put the cal AWEI. Okay, so I take the variable name look like that. And now I want to make a function. Okay, so just I create a function, and in this function I want to extract the water body, only water body pixel. Okay, so for that just put here that function keyword and put the element name. You can put any name as the. Okay, so now from here you can get, okay, so this result show the similar product. Okay, I think it's better about that. In this time here we can get type of result. Okay, I run the code again. Okay. And if you check, click on hand inspector tab, and I click suppose this type of red color. You can get this type of milligram per liter about that, how much TSS is available for that. Suppose I click on here this type of blue color. We can get that very low, 404. Okay, so this type of blue color identify about that low concentration about that total suspended solid, and this type of red color identify about the high concentration of that total suspended solid. When I click on the red color, it shows this type of red. We can get the high value, okay? And unit is the milligram per liter. Okay? So the same code, in this I can see. In this code, mainly also added the times recharge also. So I'll show you that how it will work for the times recharge. So after creating this type of things, here you can see we can get this type of. We are just simply call our collection and add all of function variable name, function variable name, function variable name, and also max water body. And further we will just try to add the visualization. So simply call the TSS and then click without study area. And now we want to make the time series chart. So for the time series chart, we are use this type of code. So we are just use our UI chart image dot series by region. Okay, UI chart image series by region, and call the image collection TSS. Okay, which I already created TSS. Reason is that your ROI, which is your shapefile variable name, and reducer mainly dot mean, scale is the 20, series probability, and then we put all of those things. So now it shows this type of result. From here you can easily get it. When it will be high concentration about that total suspended solid, when it will be low, okay, when it will be high, and also download the data. So basically, this is our code for that, and this code you can easily use for other study area. But for that, we have to also check the accuracy. We need the ground sample data. Suppose I want to use the code for other study, and I will show you that. Suppose it's one kind of water body. So now what can I do? I simply remove my previous ROI and then take the new ROI about that. Simply select and just draw this study area. Suppose it is draw. Okay. And now I put this name as the ROI. I put the name as the ROI and then check it what's happened about that. It will work or not. Just I simply zoom. Okay, so basically this result show for that 2017 to 2021. Okay, 2017 to 2021 average result. So that's why you can get the very high concentration about that turbidity. You can see it's the very high concentration. Therefore, I want to check for only for the 1 year. Suppose 2020. Just like change the time. 2000, 2022, 2022 1st January from 2022 December 31. So now let me check what happened about that. And I also use another function, suppose map dot center object, then it automatically view on the center. Map dot center object of ROI. So now it automatically focus on the center of the one. Right? Okay, so now I can see this is the result for that, only for that 1 year. You can see we can get this type of concentration result. So basically we can get this type of TSS. Suppose you want to check only for that 1 month, suppose month of January, so put at the 01.
Could you repeat what the 10 was next to the ROI? ROI comma 10?
Yeah, so this is that, it's that. So basically ROI, it's our study area. So this is the ROI.
And the 10?
And then you can simply put the variable name is the ROI about that. Suppose I have to check the another study area. Let me show you that. Suppose I want to check this water body. Suppose I want to check this is the one other water body. I want to check for this water body result. So further I simply remove the previous ROI, simply click on here and then delete it and take the new ROI about that. Suppose I just try to click on here and then just draw the rectangle. Draw the rectangle. And further I simply put here this name is that ROI. Okay, I need the result for 1 year, 2022. So then click the run. Then this time it show the result. What is the condition about that total suspended solid for this water body? It generate this type of map. Here you can see. I simply uncheck it. So now we can get this type of map.
But so then the 10 doesn't do anything?
Which one?
The number? Like the number 10?
Okay, so it's a zoom level. It's a zoom level. Suppose
okay.
When I put at the 1, it's the low zoom level. When I put the 10, then it is the high zoom level. So this value is from 0 to 24. It's the range about the zoom level. So now you can get this type of result about this water body. So basically we can get that river bank, the high concentration about that, because there are a lot of organic matter is available for that when you want to work. So let me check the another study area. Suppose I uncheck it. Suppose this is another water body. Suppose I want to check it. For that, simply take the rectangle again and then draw my study area like that. And then suppose I just simply also increase it and then it's, and I put this name, it's a ROI. Now click run. So now it show the result for this study area. We can get it's more clear water body. Almost there is no turbidity or there is no total suspended solid. We mainly find out the total suspended solid only for this study. You can see zoom it. And it worked very well. You can see we can get for this water body, but that high concentration about that total suspended solid. this type of water body. And also you can see we can get some also in here, but other almost show the fresh water. We can find out only for the high concentration for this study area. Also
Okay.
get some in here. It's the show the about also you can see for this the high concentration. For any water body, you can easily work with that. But for the check the accuracy, we need the ground sample. Suppose when you want to check about what the accuracy of your satellite data which you created, now you have to check the accuracy. Then we have to use that ground truth sample data. Suppose I have to check about that Red Sea water body. It. So for that, I just simply click on remove the previous RY and then take this rectangle. And further, I simply draw my study area. Further, just click to I put rename it as a ROI, and then click on the run. So now I can get the result for this water body. What is the condition about the total suspect quality? And I want to check it for suppose it look like that result. So I want to just pressing that's 98%. Then we have to get the more better visualization. Just apply. So now we can get this type of water body. So you can get that high concentration. Basically, for this water body, you can find out the salinity, high concentration about that. But turbidity or total suspension, this is what mass. This type of region is the high concentration about that. And it's also about the time to recharge also of each parameter. When a high load, we can time to recharge. I'm trying to check from here some from here. Suppose I want to check about this leg. But then we are just trying to add the new rectangle and draw this study area. And then put this name, the ROI. Now click to the run. Just click to the run. So now it shows the result. What is the condition? Not much concentration about this time. Pattern. And also show about the time to recharge from here. When it will be high, low, we can easily get it from below. And this unit is that milligram per liter. Milligram per liter. Salt take, we try to take it. So just try to remove that. Previous one. Then take the training. Take a rectangle from here. Suppose this is my area. And I put this name, the RY. Click to the run. Sometimes we get this type of problem. You can see here it show this type of other study area. Okay? Not show my whole study area. So for this time,
Mhm.
what we can do? Just for time, I just simply decrease study area. Okay, and we have also need to increase the cloud cover level, because in this time you can see some part is missing. It means that for this study area, less than 1% image is not available. So further, we have to increase, suppose less than 5% and try to check.
Okay.
Okay, so now it's what you can work look like that. Um, so now you can get this type of result. So we can get this is the high concentration amount that. Find out from that. So basically, when you did not, some result is missing. So for that, you are just increasing the cloud level, because all suppose basically in the water body or river bank or coastal area, it's very tough to find out that less than 1% image or 0.1% image is very is not available all time. So for that, you
Okay.
want to check it. If you it's not working, for that you can simply increase this your time scale. Okay, basically increase the time scale, or if you want, you can also increase the cloud cover level of that. Then I hope it will work.
Okay.
So we will try to make what happen. So now I can get this type of result. I can see it also worked very well, because in this time for this study area less than 1% image is available. So that's why it worked very well. We can easily get this the study area, and basically this leg for this we can get that high concentration from here. For example. Yeah, yeah. For cell see, I have to check it. Check what happened for our result. So just click and draw this area, and then put this R1 and then click the one. So now I can get the result about that salinity. We can get this type of result. And if you want to increase the value, suppose I want to need the result for 1 year or 2 years. Suppose I need the result for year of 2020, 2 years. So click the one. In this time, you will also get the more better result, because in this time, 2 years satellite imagery create this map. When I increase this time period, we also get the more better imagery. So now this result show for the 2 years average concentration of total suspended solid. Total you can see plant amount. Or if you want, you can simply click on here. Just stressing 98%. Now apply. So I can get this type of result. You can see. Okay.
So is the map showing you one image out of the 2 years?
It's about the 2 years mean imagery result. Suppose 2 years, I find out total, suppose 121 images. So all of images
Mm-hmm.
create this mean composite, mainly average result.
Oh, okay.
Average get from that total 121 images. And you can find out this type is the high concentration for this leg. So basically, this is the process for the total suspended solid, and for how we can really check the accuracy about that. It's very important for the accuracy. Suppose this is the map, what the accuracy I can get from here. So for checking the accuracy, we take some training sample. Suppose click on here. I then take the new layer. Okay.
Mm-hmm.
And further, I just open the geometry. Suppose I put it's a point. So point. And then I just take some training sample. Just click on the point. Suppose click on here. So suppose I take the training sample from here. So it's my one. Suppose I take the more another. Suppose I take from also here. Is the another. Suppose I try to take the training sample from here. Okay. As well as also take from here. Also take from here. Suppose also take from here. Take from here. Okay. Suppose I take the total 10 point. Okay. So this, suppose this is my data, and I want to extract the data from here, from this 10 point. For doing these things, just I take a variable. Suppose I put the variable name is that training. Well, I call the TSS image collection. TSS image collection. And then paste here and select the TSS band. And then use the function, this function called that sample regions. Okay, put all upper argument one by one. So just I make a curly bracket start. And also curly bracket in. And in this time my collection is that I already create the total 10 points. So it's my collection. From that I extract the pixel value. So just I simply call the point because it is stored to the total 10 samples point. And further I just paste here collection. And properties. So for the properties, we set the properties. Suppose I set the properties is that class, and I simply click on here, feature collection, create the property, and set the property name, suppose class, and set the value for 0, and then okay. Just like set the property name as a class. Scale is the resolution. I put the resolution such as 10 meter for sentinel 278 imagery. If not, remove that. So now in this time, whatever you can see, I just simply print that. So print is training, and then it will run. So now it show you all of total 10 points result. So now, okay, so it's working. So now here you can see about that collection. The collection, I call the collection. Put here the collection. So now let's check. Let's look. Okay, I take the mean value. So now it's working. So now we can get the average result in here. You can see computing the feature collection. We can get the total 10 points average result. It's computing. Okay, 10 points. Click on here. And also click on here. You can see that feature. Suppose you can get all of feature in here. You can see. Two property you can get from here. You can see. The TSS can get this type of value. Also click on here. You can get this type of value. And also you can see about it provide all of TSS value for this individual point. The point about. Also click on here, you can get the point. And if you want to check about their geolocation, what is the latitude longitude? So for that, click on the in here. Here you can see it provides that all of point geolocation. You can see it provides that your specific geolocation about that. Basically, this is the coordinate about that. The coordinate about. So for calculating the accuracy, so first of all, we try to open an Excel file. Excel file. We just get a data sheet, look like that. It's create. In this Excel file, we are just put some value. Suppose I need the one column for that. Add latitude and longitude, and also put the TSS. Okay. So in this time, where I can get the latitude and longitude. Suppose here I can see, I can easily get that. This is the latitude and longitude value. I simply copy from here. Copy. And then paste here. And for the longitude value, it simply copy from here. Copy this value and paste here in the longitude. And just put the value. And also TSS value we can get from here. So basically it's the first point. So for that first value is that. Suppose simply open that feature 0. And you can see this is the TSS value about that. So simply copy this value and also paste here. Okay. So just you can simply draw latitude, longitude and also TSS value for total 10 points. And it's come from our satellite imagery. Okay, so this result we can get from the satellite imagery. At the same time, suppose we want to also go to the field and for the same location, suppose for the same location, basically same coordinate. For the same coordinate, you also try to extract the ground sample. Okay, suppose simply for the same location, you can simply go to the ground sample. So in this time, suppose TSS value, I will get the TSS value from satellite data and another TSS value I can got from another TSS value from ground sampling. So when I can get, suppose one sample is for that TSS value for the same location, coordinate is the same. For the TSS satellite value, I also get for the TSS ground sample. Suppose I put the ground sample is that 10245.00005. Suppose I can get this type of value for that ground sample. Okay, after testing the TSS, this value is that milligram per liter. Okay, and also TSS value from here we also get that milligram per liter. Okay, so suppose we have the total 10 point about that. We can get that same location. You have that TSS value from satellite data and also get the ground sample data. Those 10 values. So further, these 10 values we are used to make the accuracy assessment, okay, using the confusion matrix table or any other, or RMSE, root mean square error, or anything. We are just trying to check the what we can get that satellite image data and where we can get the ground sample data. Okay, so then we can easily check the accuracy. So further, I also show you that how we can easily create this type of things using that. So I hope we can easily get that how we can easily check the accuracy after creating this type of map. Okay, so basically for that we need the ground sample data. So if you don't have any ground sample data, don't worry that I already work with that. I also have some ground truth data. Then I use my own data and try to show you that how we can easily check the accuracy about that. So basically for the accuracy we need to use the same point. Suppose this point, what is the value about that? And for my ground, for this point, what is the value about that? For first, you try to the sample from the ground, and then